Swayam Prabha. Digital India. Educated India.
Good morning, everybody. Today we are going to discuss another important application of vacuum technology, this time for a very noble cause of giving power to the society using an infinite source of energy, that is solar energy, possible only because of vacuum technology. So, that way vacuum technology is playing a very important role in the present day scenario, where there is need for lot of energy for day to day life and without any pollution. So, this is not possible unless you go to natural energy sources, renewable energy sources. Sun is, of course, is the main source for all of us, energy source, and sun is directly or indirectly responsible for all the processes that are going on in the world, and lot of energy is continuously falling on earth. If only we can utilize this, harness this energy, there is no need to pollute any of this nature. We can nicely utilize the solar energy. Of course, in the world all the countries are working on this solar energy, because solar energy is boundless and naturally available, and only thing is we need to have a technology for it. Luckily, in the last 50-60 years, after the discovery of semiconductors and after the famous discovery of Einstein photoelectric effect, and of course, heating effects that we normally feel even in our day to day life. Without our knowledge, we know we are using solar thermal. So, like that man is continuously thinking how to use this or how to convert this solar energy into an electrical energy, which is a rich energy, because once you have electricity, you can use it through wires anywhere and you can have comforts. With a little bit of care, you can also concentrate solar energy to produce heat, but technology is somewhat different from the electrical energy, but both are very useful forms of converting solar energy, in which vacuum technology is going to play a very important role. So, today we will see these two technologies and the role of vacuum in that. There are quite a good number of books on this field. In fact, it is a very big field. Most of the people, even common man, knows about it, because even on rooftop we have solar PV cells, and even olden days people try to use some of the vegetables etc. for drying under solar energy, and solar cookers are available even for housewives. So, everybody knows about it. So, we are not going to discuss fundamentals of solar energy spectrum and radiations and conversion methods etc., because that is a big field by itself in the energy engineering, renewable energies etc. But what is it we are discussing today is, it is a part of vacuum technology and process applications. So, we are mostly interested in vacuum aspects of it and how vacuum is assisting in the process of converting this solar energy into useful electrical or thermal energy. So, I will focus mostly or I will talk mostly on vacuum related aspects, even though I will touch upon the principles of solar energy conversion little bit. So, the concepts that are going to be covered in this lecture are vacuum for silicon production, because that is the most popular abundantly available source, silicon, which is a semiconductor getting from sand, which is silicon dioxide, and vacuum for solar cell fabrication after getting silicon. Then solar module developments which are friendly to the common man, and how do you handle these big things to produce electricity out of it. And apart from electrical aspect, how do you get thermal energy out of solar radiation, and how do you focus it, how do you utilize that again to generate electrical power, and where the vacuum is playing a role in both the solar PV and solar thermal. That we will be working on today with some conclusions drawn at the end. Though you do not need an introduction to solar energy, but it is customary for me to give you some feeling of solar energy, but I will treat it from vacuum window. Okay. Here you can read these popular notes, these are available in Wikipedia, much better notes than this. Okay. You can go through it. With greenhouse gases accumulating every day, now it is high time that people start shifting from traditional electricity generation to produce other style of energy production, that is electricity based on solar energy, wind energy, or ocean energy, ocean thermal energy, tidal energy, like that, out of which solar energy is very popular, because it is just available above us. In fact, sun is a god. Okay. So, God is above us and he is trying to shower energy continuously. Of course, we get tired when it is very hot, but the solar energy points will be happy if more and more bright the sun is. Okay. So, the strategies for converting this solar energy into useful electrical and thermal energy are based on solar photovoltaic effect and solar thermal processing. I will not go into the physics aspect of it, which I already told you. My idea is to convert this solar energy into thermal or electrical energy utilizing vacuum aspects. There are material aspects, there are semiconducting technology aspects, there are so many varieties of technologies involved in it. It is not an easy task. Broadly speaking, in solar PV cells, what are the important steps? Manufacturing first a pure silicon. Silicon by itself is not available out on earth. We have to generate silicon, and that too in a crystalline form, polycrystalline form, but fairly pure form. If you do this in an oxygen atmosphere, it will be silicon dioxide, which is sand, which is an insulator. We want silicon. So, naturally the processes should be oxygen free of producing silicon. First you produce silicon, then do some doping, then make a p-n junction, then passivate it or put some insulating layers, that this panel it, and then make a rooftop. A lot of steps involved. First you should have a silicon, and silicon ingots are made using various techniques. Silicon itself is a metal. Okay. And extraction of silicon from natural sources, that is in another story. I am not going to do that, but I wanted to tell you that even in silicon production itself, vacuum plays an important role through some chemical and physical routes, or putting a seed crystal and then pulling it from a tub in a hot conditions, how to make a big cylinder of silicon and cut it into various wafers using very high modern techniques. It is a big technology by itself. If you see the supply chain management of silicon wafers, you will get lot of articles. So, my point here is the vacuum is involved in manufacturing pure crystalline silicon wafers. I will not go into detail because of lack of time. And after that again vacuum comes into picture by doping of fine quantities of p type materials or n type materials to make p-n junctions out of it. p-n junctions are better candidates for solar energy conversion compared to pure materials. Even any material for example, has got some photoelectric effect, okay. But the effect is very good in semiconductors. It is all the more when you make p-n junctions with certain modifications etc. Well, that is a field by itself, semiconductor physics. Then we need to metallize them, because these are like a mini cells, batteries. So, we have to connect them to make voltages or current carrying capacities of different levels by connecting these cells in parallel and series and through metallic contacts. So, metallization is very important, and you have to laminate it, what we will see later also, with some insulating layers, and again put it in boxes with perfect transparency, all these things, so that even natural disturbances will not harm these panels. Otherwise, dust collecting or temperature fluctuations or any earthquake or any such a wind gale storms will disturb the whole thing. So, any technology should be viable for a long term. Okay. So, lamination is very important. Joining these cells to make big panels, that is engineering finally, that is important. Recently, apart from this silicon based PV cells, there are also other semiconducting materials which are competing like cadmium telluride and CAGS. They are on glass substrates. You can utilize the physical vapor deposition or chemical vapor deposition. We have discussed in thin film deposition technology earlier. Okay. You can go through that, because in this vacuum technology course there are some common factors between 3-4 lectures. On one side system design, other side chamber making, then deposition, then leak detection, all of them are again coming here also indirectly. So, I want you to understand that more rather than only materials aspect of it. So, either silicon based or cadmium telluride based, all of them require vacuum somewhere or other in manufacturing wafers or manufacturing thin films or doping them, metallizing them, connecting them, or putting a layer on top of it, protecting layers, in all these things. This is one story. Other side, solar thermal energy conversion, this is also very important. It will not be as comfortable as solar PV, because once you get electricity, you know how to use it or how to misuse it. Sometimes nowadays people forget to switch off. Solar thermal, you have to also be there to monitor things etc. Solar thermal is also entering in a big way nowadays, again thanks to vacuum technology, because vacuum can have a thermal insulation aspect of it. Vacuum can be used to make very large scale coatings on mirrors of highly reflecting coatings with emissivity coming almost to 0.05 etc. Then evacuated solar collectors with absorbing layers, which are again deposited by vacuum to absorb this solar radiation, convert into thermal radiation, but in return journey the energy, thermal energy is not lost, because convective heat transfer is minimized by evacuating the surroundings. It is called evacuated tube collectors having thermal absorbers, solar absorbers. This is a technology, okay, and they can be integrated with power plants then to get solar thermal power. Okay. So, that way either you get direct electricity and with suitable electrical gadgets like rectifiers or transformers etc., you can directly connect solar energy from voltage to the grid, or you can get some electrical gadgets inside, some controllers and circuits to get useful friendly AC power inside the house at the necessary frequency and voltage. If excess power is generated, using these PV cells, you can also give it to the grid. There are ways to do it, electrical engineers know it very well. This is a solar thermal power plant. Here also I told you already, highly reflecting parabolic mirrors, and the axis of it there will be a double walled evacuated tubes through which thermic fluid will be flowing, and there are different technologies to utilize this thermal energy associated with thermic fluid, which gets hot from this focused heating aspect of it, and that will be given to the water to convert steam. Once steam is produced, we know the electrical engineering, how to run the turbine and produce the power plant, etc. So, we have solar PV power plants and solar thermal power plants. Technologies are slowly getting developed better and better. I can't say they have reached a perfect level, but it takes time. But once they are coming in a big way, we can forget about utilizing fossil fuels, whether it is a coal or wood or natural gas or petrol or anything. We can also forget about dangerous situations like nuclear fission type of radioactive things, provided these technologies are user friendly and reliable and rugged. And this reliability ruggedness is intricately related to vacuum technology. This people are not aware. So, that is what I am trying to give you, whether it is depositing layers here, you require vacuum. To make silicon wafers, you require vacuum. To make reflecting coatings, you require vacuum. To make double walled tubes where the electromagnetic energy is converted into thermal, but thermal energy is not being dissipated back again, and all these things involve a great deal of vacuum technology. So, that way most of the processes in PV as well as solar thermal technologies, they utilize vacuum of different levels, medium level, high vacuum level. Coating requires 10 power minus 5 torr if it is a PVD. If it is a CVD, it is a pure minus 1 torr, minus 2 torr, but very pure, it will be purging. The purity levels are very high. 10 power minus 2 does not mean there is a partial pressure of oxygen there. No, partial pressure of oxygen in that 10 power minus 2 is 10 power minus 10. So, again you require residual gas analyzers which are vacuum based, mass spectrometric leak detectors. Here itself I want to tell you, you may have 1 torr, but 1 torr with 10 power minus 10 millibar liter per second leak rate, which is very important, like compressors in refrigeration plants. Once you put there, it has to run for 20 years, 10 years like that. So, leak rate is very important there. Even if you have high vacuum chamber, if it is continuously being evacuated by a pump, leak rate need not be very high. It has to compensate the throughput coming from the process and leaks, and continuously pumps are running. These things we have seen in the case study of metallurgical furnaces earlier. So, all those concepts you have to think, so that you design right vacuum systems for such solar thermal or solar PV projects. So, the figures are just an indicators that very soon these vacuum based systems are reaching home, and they are going to replace conventional power plants. And see, the panels will look like this. These are final things, but you require silicon first, then wafer, then doping and metallization like this. Whether it is a polycrystalline or monocrystalline, you have to decide. Certain things are very costly, and if you do not require that perfect, you do not go for single crystals, and even on single crystals you may have to put polycrystalline coatings again. After that, using lithography and other things, we may have to have some channels made. After that, we will go for p type or n type dopings, and multiple such cells are interconnected, and finally you get series and parallel connected cells and various panels to produce the necessary voltage. I will not discuss the physics behind all these processes, nor I have time for it. So, what I wanted to tell is, even the solar cell materials at various levels, whether it is in the film tape shape or in the ingot shape or in a thin film type or a small flake type or metallization type, all these processes require vacuum pumps. And in the process of silicon production, lot of dust will be there, silicon oxide dust will be there. Okay. So, when you are producing crystals or when you are making thin films, etc., large scale production. So, you have to be very careful, the pumps should be able to handle these things. And nowadays, of course, there is a tendency to use dry vacuum pumps like screw pumps or claw pumps, or even if you use rotary pump, oil free type of thing should be used, and oxygen should be as much as possible reduced. Otherwise, silicon any time under hot conditions will be converted into silicon dioxide and it is no more semiconducting. So, you have to be very careful in that style. Okay. And roots blower of course, is always used to enhance the pumping speed of these medium pumps. So, that you will get a working vacuum of 10 power minus 3 torque, which is good enough for thermal vacuum when it is come to solar thermal systems, okay, for his evacuated tube collectors. So, variety of pumps have to be planned properly depending on the availability and budget. Then once you have panels or flakes or whatever your shape of various shapes of silicon, then you have to make panels at various levels, cell level or module level or panel level, an array of levels, and different layers from microelectronic aspect of it. On a silicon wafer, you have to have indium tin oxide, which is a transparent coating, but at the same time it will allow your radiation to fall, but it will not interfere with your process. Similarly, there will be some protective layers on top of it. So, lot of multi-layer depositions and multi-layer coatings are required using vacuums of various levels, whether to make panels or whether to carry them or assemble them, or at microscopic level whether you make the materials in the film of different layers, they are all in micron level. So, vacuum technology plays a very important role. These things have to be handled in leak tight chambers. I am not showing all that, nor I am discussing this physics, because that takes a lot of time. I am only telling the cleanliness is very important in semiconductor industry, in IC chip manufacturing. Similarly, here it may not be that stringent here, but definitely vacuum is an important aspect of it for removing dust, or because for example, PECVD or PVD in plasma enhanced chemical vapor deposition is coming up in a big way. Even doping and diffusion in a controlled way require vacuum, and wafers handling at various levels involve vacuum, and handling them also involves vacuum, and call it every step including soldering, including metallization, everywhere you require vacuum for this. Once these panels are made, to handle those things, that also requires clutches, robots. We have seen in packaging also similar structures. To lift such big panels precisely, either for transporting them or to keep them or laying them on rooftop, etc., you require very precise lifting. That is possible again by vacuum. Vacuum not only makes silicon, or not only makes various types of layers to realize PV cells or to make panels, it also helps us to lift things and lay them properly for an application. And I already told you encapsulation is very important at various levels. That popular thing is ethylene vinyl acetate at high temperature in a vacuum chamber. Again, it has to be coated on these finalized panels, so that weather will not disturb it, and here again very good quality vacuum pumps are required to handle these EVA materials, and protecting them while arranging them into panels, etc., while encapsulating them, everywhere you require vacuum of it. So, the right choice of vacuum which can handle this is of vital importance. So, a designer has to think, you should not put a small pump, unnecessarily you should not put a large pump. Depending on the vacuum level, he has to say whether -3 or -5, and what is the throughput that is required. If it is a mass production, the pumping speeds have to match at that pressure the throughput coming from the process load. These things have to be thought from the vacuum point of view, while development of solar modules or handling of modules. Okay. Then little bit of story, different story, which I have already explained you in the beginning, but so far we are talking again and again what PV says, PV. That means photovoltaic, direct conversion of electromagnetic energy into electrical energy, and then finally with suitable treatments how do you give it to produce a massive electrical power for day to day applications. And today almost all the countries are involved in this game of solar PV, and that is why this is also one of the biggest customer for vacuum technology now. Okay. So, those people who would like to take up startups, they can make their own PVs or solar thermal tubes, etc. They are coming very cheap now. A typical panel like this is just kept on a rooftop, it is so cheap, few thousands of rupees. Similarly, such double walled vacuum tubes, which I will discuss now for solar thermal, very cheap, 500, 800 rupees type of things, coatings on this, very cheap coatings. Okay. So, as per the current solar thermal market trends, the market is dominated by evacuated tube collector segment. There are other ways, directly you can take the solar through a reflector and put it nearer to a food gets heated up. These are conventional methods, parallel plates like that. But unless you concentrate them, the temperature will not increase. The parallel plates are just collecting things, energy, like when we stand on the in the outside, we will also receive solar thermal energy, but our temperature will not go up like anything, but in concentrated collectors you can go up to 500 degrees centigrade. How do you concentrate it? You take a big, very big structure. This is not a small structure. This type of structures, multiple structures will be there in a park. I think I showed you in the beginning. Yeah, here this is a park of solar reflectors. Each parabolic reflector I am showing here, and at the focus of this parabola you arrange a double walled glass tube. That means, there is one inner pipe, there is one outer pipe, the annular space is evacuated, and inside that thermic fluid can flow, or you put a copper pipe with some fins for better heat transfer. There are ways to do. This is not the actual picture of how it looks like. This is one way of doing it. Several people use several technologies, including heat pump technology. You can integrate all your heat transfer fundamentals here. Once the energy gets concentrated onto this focus point and falls on a black coating, which is a black body, it absorbs all the energy, but return journey of that thermal energy is not possible because the annular space is evacuated. Since they are glass pipes, electromagnetic energy, light will go inside, it will fall on the black coating which is on the outer surface of the inner pipe, that is also a glass pipe. Now, there are some copper coatings also to make it sticky better, and copper should also increase the heat transfer coefficient to the inner side of it, and there are variety of multi-layer coatings, finally to make an absorbing layer sitting inside a evacuated space. So, here you can see the cross section of this pipe, outer glass pipe, inner glass pipe. So, this is my outer glass pipe, this is my inner glass pipe, and this entire annular space is evacuated. Inside there is a thermic fluid that picks up this. So, radiation, electromagnetic radiation goes through this glass pipe, falls on this inner glass pipe, but it is coated by an absorbing coating, that selective coating, which is a black coating, and the energy gets converted into thermal energy, but thermal energy will not go back because there is a perfect vacuum. So, convective heat transfer is not there, only little bit of radiative heat transfer and some conduction heat transfers towards the end side of it, where some support structures have to be there or spacers have to be there to make all this concentricity, etc. Some small heat transfer can be there, but major heat transfer of convective heat transfer is not there. So, electromagnetic energy is converted into thermal energy without any loss, it gets accumulated, and this is a focused energy. You must have seen when you put a lens, you can burn a paper. In childhood we used to do that, okay, because it is focusing parallel beams which are falling on this coming from the sun, they are now focused onto this focus. It is a parabolic, a section of this parabolic reflector, and the top of it is highly shiny. This is possible by coating, aluminum coatings. You can take a simple aluminum pipe, aluminum sheet also, but that may get oxidized. So, recently what they are doing is, they are taking some plastic sheets and coating on it. It is a flexible plastic sheet that can take the support of a background, even iron structure, and so that it will finally look like a front surface will finally look like a highly reflecting surface, that is all. So, again thin film coating unit using vacuum is coming here, and evacuated tube collector vacuum is coming. You can put array of those things simply for heating at home front, or you can like this, or you can put it in a concentrated type of things to produce thermal energy to a level of 500 degrees using such collectors. These collectors are commercially available, you can purchase, you can make also at home. You can make this at home, and thermic fluid, you can make a small plant at home, maybe some people together can make, it can be a startup. So, basically evacuated tube collectors, what they do is, they are double walled glass tubes with high vacuum in the annular space. A black absorbing coating is applied on the outer surface of the inner pipe to absorb the radiation coming from the parabolic reflector. This reflector not only reflects the coming radiation from sun, but also focuses it because of parabolic shape. The evacuated absorbing tube is located on the focus point like this. Several such things will be there depending on the total energy requirement, that is called solar park, solar thermal park. That thermic fluid will take out this heat continuously, give it to the steam chest where steam is produced. Once steam is produced, power plant people know how to put that to run a turbine, so that it produces electricity. So, this type of solar thermal power generation without using any fossil fuels like coal and oil and gas is not possible unless you use vacuum technology. Okay. Without using any fossil fuel, I stress on it. So, pollution control is automatically taken care, and where the vacuum technology involved, I am reminding you again, it is involved in coating the reflecting coatings as well as absorbing the electromagnetic energy into thermal energy, and another vacuum is there here, annular space, to reduce the convective heat transfer. Vacuum in PV cells is thin film depositions and making single crystal pulling in a vacuum space, creating a very beautiful chemical vapor deposition type of tubes where purity of the gases are extremely high. So, purging it to high vacuum is required, and focusing an ion beam for etching certain things after lithography, or putting a sort of diffusion, forced diffusion by plasma assisted diffusion. So, all sorts of technologies, they utilize vacuum in the PV industry, but in thermal industry they use for thermal insulation and absorbing coatings. Okay. So, this is also equally competing, only thing is it is solar energy converted into thermal energy using vacuum. There solar energy is converted into electrical energy with various coatings and other processes. There they use silicon, here we use black coatings. Okay. So, this way vacuum is helping in both solar PV as well as solar thermal energy conversion. So, in conclusion, vacuum technology plays a very crucial role in manufacturing photovoltaic cells and evacuated tube solar thermal systems. In photovoltaic cells, I remind you, vacuum technology is the key for every sub process, whether it is a wafer manufacturing silicon wafer, or a semiconducting layer deposition, or a controlled doping of P type or N type materials, or protective lamination, or a panel handling, even lifting and precise locating. Okay. In solar thermal plants, the evacuated tube is playing a very important role for heat transfer, and absorbing coatings and reflecting coatings on mirrors as well as tubes, they focus this and convert into thermal energy and give it to the power plant without the necessity for any fossil fuels. So, with the help of vacuum technology, infinite supply of solar energy, which is naturally available thanks to God, sun, can be, this energy can be tapped to produce electrical power and industrial heating, which are very much required, okay, without any environmental pollution. Once you have energy, you can also use it for refrigeration. So, heating, cooling, handling, working, every aspect of life can be related to solar input through vacuum based PV cells as well as vacuum based solar thermal collectors. So, with this I feel startups can come up in a big way in small scale, medium scale. So, I request all of you to read it in the internet and get benefit out of it. Thank you very much.